Welcome to Code Jumper. This is a lesson about computer systems. In this lesson, students will learn the basics of what a computer is and how computers can improve people's lives. Those are the basic lesson objectives. The expected outcomes are that all students will be able to give examples of computer systems. Most students will understand what a computer system is, and they'll be able to give examples of how computers can improve people's lives. And some students will be able to explain to someone else what a computer system is and how computers can improve lives. The key vocabulary for this lesson includes the word computer, which is an electronic device for receiving input, storing information, processing information, and then providing an output of information. Those things all have to do with a computer, but we're also going to talk about those words. The word input, which are signals or instructions sent to a computer. The word store, which in this case means saving information in order to be used at a later time. Processing means the changing of information into a useful format. Output is data or information that is created by a computer. And we're going to cover what a tool is, which is basically a device that does a task. The first part of this activity is an unplugged activity. The objective of this section is to introduce students to the concept of what a basic computer is and how it can improve other people's lives. Students will be working in small groups. If it works in your classroom to have 2 or 3 students together, that's an ideal number. They'll need some type of note-taking materials, possibly a computer science journal, and maybe a whiteboard or a screen where you can record their responses together. The beginning of this unplugged activity is an opportunity for students to brainstorm tools. Have them identify what a tool is and what tools we have around us. Maybe everyday tools, things like tools for what we use in the kitchen, tools that we use outside when we're building things. Have students in their small groups write these tools down somehow in their materials. Either one person can write them down, or you could do touch typing. Just start getting their juices flowing about tools in general, what the purpose is for each tool. After a few minutes, students will identify the tools that they've brainstormed and share with the group what those tools do and how they're used in our world. To start off this unplugged activity, students are going to be in small groups of 2 or 3 if that works for your situation. And they're going to brainstorm tools. What is a tool? What's the purpose of a tool? What tools do we have around us that we use on a daily basis? Then, in a larger group discussion, we might have students share what tools they thought of and kind of just discuss what those tools are and how they work to help our lives a little easier. What is their purpose? They might discuss how these tools can help us with everyday life or with doing certain tasks. Then we're going to move to brainstorming examples of things that are done with computers. I'm sure students can come up with all different kinds of devices in our world today that utilize computers. Computers are tools too, and we want to help students recognize that computers help us solve tasks or solve problems sometimes. In order for computers to work with information, they need to do 4 different tasks. First, computers need to be able to input information from an external source. So I like to equate this to students similar to what a calculator would do. When we touch a key on a calculator, we are pressing the key with our finger or with an item, or somehow we're depressing and choosing that key. That's an input. The computer takes that as input. Then the computer stores the input. So if we press maybe a few keys in a row, the calculator, is going to store the keystrokes that we put in. So if we put in 8, and a plus sign, and then we also touched the 3 button, the calculator would store that. The processing part is kind of like thinking time. If you give your students thinking time after you ask a question, you could equate it to that with a computer or a calculator. It is processing the information. At that moment, it is adding 8 and 3 together, and then the output that a calculator gives you on the screen is usually an 11. It has done all that work and it is giving you a number as an output. We'll want students to record these 4 vocabulary words in their computer science journal. This is a great opportunity to start the habit of utilizing the computer science journal. However it works for your classroom, if students are sharing or they're working together, somehow actively putting this information down so that they can come back to it later if they need to. After students have an understanding of these 4 vocabulary words, try going back to the list that was created of tools, computer-related tools, and see if students can identify the input, what is maybe being stored and processed, and what the output is for some of these devices in our world today. Next, in the guided activity, students will get an opportunity to start identifying input and output and process and store with CodeJumper itself. We're going to cover the same vocabulary words. And with this activity, you as the teacher are going to need a hub and 3 play pods and a device with the CodeJumper app. This is going to be students' first experience with CodeJumper, possibly, and so you might want to use this opportunity to set up some habits, good habits, for how to work with the CodeJumper kit. So this guided activity could be simply a demo where you utilize students as maybe volunteers to come up and interact with one piece or one part, or you could have students follow along, but it's going to depend on the age of your students and how comfortable they are using brand new materials. So I'm going to go through this as if I were going to demonstrate most of it and have students engage with me for just a piece of it. I'm going to start by showing on the document camera the pieces and parts of CodeJumper. So let me pull that up on my screen. And I'm going to review, in case students have never experienced CodeJumper before, I'm going to sort of model for them how to turn it on. So the first thing is to identify the hub. On the screen right now I have the hub and 3 play pods. And before I go into it further, I'm going to make sure that students can identify the hub based on the way that it feels. There's a large flat speaker. The hub has a dial that I'm actually going to turn on right now and slide it up, and I'm going to hear a click when it connects to Bluetooth. The hub also has a large play button with an inscribed triangle and a smaller blue button with a square that is the stop button. And there, it's connected. Make sure the volume is up so students can hear it. The hub also has 4 notched ports where you can insert the plugs from each of the pods, which we'll get to in just a minute. Once my hub is connected, I will want to make sure that I'm connecting for students that there's something that happens physically with the CodeJumper kit, and it also happens on the app. And so on the left-hand side of my screen, I have the app up, and I'm going to, just for the sake of simplicity, I'm going to change the sound set in thread 1 to animals. So I'm going to walk this through with students so that they know exactly how to make sure they have the right sound set when it's their turn to play with CodeJumper. I'm going to select the box on the first, where it says thread 1. Right now mine happens to say twinkle twinkle. I'm going to choose that, and a new window pops up. Sound category, sample sounds, sound set, twinkle twinkle. And I would like to change it from being twinkle twinkle. So I'm going to choose the drop down menu and scroll up and select animals so that it says sound set animals, and I'm going to choose OK. Now my thread 1 says animals in the app. We don't have anything connected yet, so just the hub is on at this point, and it's important for students to know that this is sort of your starting point. This is where you want to begin. Next, I'm going to walk through and show students and kind of describe what a play pod is. Right now on the screen, I have 3 play pods up here, and I'm just holding one of them. It is a white mouse-shaped pod with a cord at one end and 2 dials. This one dial has short, sort of flat dial, and then there's a taller ridge dial. You might want to help students identify that this is called a play pod. And when I am ready to use the play pod, I'm going to insert it into thread 1 of the hub. And when I do that, I'm going to hear a click sound. Oh, and it also gave me a horse sound at the same time. At this point, it's great to point out that in the app, something has changed. There is now a hub with 1 play pod attached, and there's also a new line of code in the app. So I might draw my attention to it here with my mouse, or I might zoom in on this to show students that in thread 1, animals, there is now a new line of code underneath. Some students might be very excited that they're actually talking about a line of code. And the line says, play horse for 1 times speed. Now, at this point, just letting kids observe and figure out what's happening every time is just sort of the point of this. So you could ask a student to demonstrate and come up and have them choose to plug in a second play pod. So over here on my camera, I'm going to show taking a second play pod, identifying that it has 2 dials, a tall ridged and a short flat, and taking the cord and plugging it into the port of the first play pod. So now I can hear the click sound, so I know it's attached. And I have a hub, a play pod, and a second play pod. Maybe another student will come up and we can ask them to press the play button and see what happens when you push the play button. And you can kind of do this in any order, just as long as you're drawing their attention to the fact that when they choose play, something different happens when you have 2 of them connected, and that there's 2 lines of code now in the app, because now the app says thread 1 animals, play horse for 1 times speed, and in another line underneath it, it says play pig for 1 times speed. And see if they can start noticing these changes as you describe them. So a student might push the play button. You hear the horse. They heard the horse, and then they heard the pig. And then a final student can come up and connect the third play pod to the end of the second play pod. So you have a string of 3 coming out of thread 1. And now there's a third line of code over in the app. Play horse for 1 times speed, play pig for 1 times speed. Now it's adding in play dog for 1 times speed, and then end thread. So students should be making that connection that there are 3 play pods and there are 3 lines of code now. And if they push play, 3 sounds will happen. At this point, it's nice to double check and see if students have grasped the vocabulary and if they can apply it to CodeJumper. So remember our words: input, store, process, and output. And ask students if they can start to identify that in the CodeJumper kit. So an input might be, let's see if they can come up with it, plugging in a play pod, pushing the play button. You're giving CodeJumper something, some kind of information. CodeJumper is then storing and processing the information, and the output is the sound that is played. The output is in the audio, or is what we hear. If students can easily grasp this concept, you could try adding in a quick extension. You could go into an explanation of processing. Processing is a little harder to understand. However, one way that you could explain it would be to turn the duration dial, or have students experiment by turning the duration dial to a faster or a slower speed. This knob gives CodeJumper information to process the sound differently when it is played. So it's still the same sound, but we're processing it differently, and we're changing the duration of it, or the speed of it. So if I turn one of these dials, I will hear that the pig sound is speeding up. As an exploration, I'm going to switch on my screen back to the PowerPoint slide deck. As an extension or an exploration, students can think about and discuss the concepts that have been covered so far about how computers can improve people's lives. There's a wonderful video that can be played. It's linked in the curriculum guide about an experience of the experience of a blind software engineer who works at Microsoft. Watching the video is a great discussion jumping point, and so is the app called Seeing AI, and that's another opportunity. You could download the app ahead of time and have students actually play with the app and experience it, and then understand how maybe input and output work with this app. If they haven't seen it before, it's a wonderful opportunity to sort of play with something about how computers can help other people. And that's it for this lesson.